Welcome to the CopperSpice YouTube channel, and thanks for joining us. In this video, we are going to be talking about signals and slots and how to use the CsSignal library. Signals and slots. We will start by defining what signals and slots are, compare CsSignal with the Boost Signal library, and show how to use the CsSignal library. A signal is just a notification that something occurred. A slot is an ordinary method. It can also be a function or a lambda. There's actually nothing unique about a slot. You can call it independently. A connection is how you associate the signal with the slot that you want to call. An activation is the mechanism that handles what should happen when a signal is called.
There are two signal libraries in Boost. The first one is deprecated because it was not thread safe, and the modern replacement is Boost Signals 2. In Boost, signals are represented as objects. This means that in order to add a signal to your class, you must add a data member, and this changes the size of your class and therefore breaks the ABI. While most of the classes in Boost Signals 2 are thread safe, it is not thread aware, because slots are invoked only in the thread that emitted the signal. The CsSignal library takes a completely different approach. In CsSignal, signals are represented by methods. This means that adding a signal to a class just involves adding a method and does not change the ABI of that class. If you are using CsSignal in a multi-threaded program, slots are called on the thread determined by the receiver. This means that you can emit a signal in one thread and have the slot invoked in another thread, because CsSignal is thread aware.
CsSignal is a BSD licensed library. Since it is a standalone library, you can use it in any C++ application.
In order to use the CsSignal library, you must first add signal and slot declarations to some classes in your application. Since slots are just methods, the appropriate slots may already be present. Once you have the required signals and slots, you can connect them together using the connect function. When the signal is emitted, activate is called, and it will automatically call all the slots connected to that signal.
Here is the example we are going to use. Consider what should happen when a train is approaching an intersection. Train status is a normal class, and it's going to monitor the train. When a train is about to enter an intersection, a signal should be emitted. When the signal is emitted, we want crossing to be notified and then take some predetermined action.
In the train status class, all we need to do is inherit from signal base and declare the train coming signal. In the crossing class, we're inheriting from slot base and declaring two methods that allow us to flash lights or lower the gates. In order to connect a signal to a slot, we need to call the connect function. This function takes 5 parameters, although the 5th one is optional. The 5th parameter is used if you want a slot to be called on a particular thread. It gives you options for specifying whether the slot should be invoked directly, through a thread queue, or through a blocking thread queue. As noted in the prior slide, the default is auto connection, and in most cases this is what you want.
In this sample code, we have 2 calls to connect. The second parameter is a method pointer, and it refers to the signal declared in train status. The 4th parameter is a method pointer to the slot which will be invoked. So what we have is 2 different actions will occur as a result of one signal being emitted.
The activate function is not part of the public API in CsSignal. It is an internal method that takes care of invoking slots when signals are emitted. You will never call activate directly. It is called from the signal method, which is generated from a signal declaration. We're showing an example signal method here. This is what will be generated in your class for the train coming signal. To emit this signal, all you do is call the method train coming and pass whatever data is needed. In this case, train number is being passed. The slot does not need to accept this data, but in order to emit the signal, it must be supplied. There is also a disconnect function provided, which severs the connection made by connect. Its 4 parameters are the same as the first 4 parameters to connect. So let's take a look at the public API of CsSignal. It consists entirely of 3 classes. Signal base and slot base we have touched on, and pending slot is a mechanism used in the multi-threaded signal delivery system. In order to emit a signal, your class needs to inherit from signal base. But there is no public API in this class. There are no methods provided for you to call. This class contains internal code that stores the list of active connections and the implementation of the activate function. It also contains a virtual method that you may override if you wish to change the way that CsSignal handles exceptions encountered when processing a signal.
The activate method is a variadic template, which is called from the generated signal method. It is variadic, so the method can accept any number of signal parameters and preserve the original data types.
If a slot throws an exception, activate will catch the exception and pass it to the handle exception method. The default implementation of handle exception does nothing and ignores the exception. If you would like to handle the exception in some way, you can override this method to take some action. The slot-based class provides one public method. Within a slot, you can call the sender method to find out which sender emitted the signal you are currently reacting to. There are also 2 virtual methods you can override to configure the multi-threading behavior of signals. In a multi-threaded environment, you will want to override the compareThreads method to return whether or not the sender and receiver are in different threads. You will also need to override the queueSlot method to provide a queuing mechanism so that the signal can be delivered in the receiver's thread.
So to use the CsSignal library and add signal and slot delivery to your C++ application, simply link the library in with your code. Determine which classes in your application will be sending and receiving signals, and inherit from signal base and slot base as needed.
We designed CsSignal as a standalone library in order to refactor the signal slot delivery mechanism out of CopperSpice. During this refactoring, we found problems that were in the original CopperSpice implementation of signals and slots, which only became manageable when we refactored the functionality out into a smaller and more concise library. As an example, there were race conditions in the destructor for queueObject, which we have been able to find and resolve in CsSignal. What started out as a way to refactor CopperSpice has yielded a standalone library, which is useful if you would like signal slot delivery in your program, but do not need all of CopperSpice.
The repository for the CsSignal library can be found on GitHub. You may also want to take a look at the unit tests to see some other ways of using the library. CsSignal, CsString, and libguarded are all standalone libraries you can use in any C++ application. They are also leveraged by CopperSpice.
For more information about CopperSpice, as well as the other libraries we maintain, please visit our website at www.copperspice.com.
Thank you for watching our video. We hope you found the content of value. If you have any questions, feel free to email or leave us a message on our CopperSpice form.
Please make sure you subscribe to our YouTube channel and come back in 2 weeks for our next video.